I'm ready. Oh. right, you're welcome back to our exercises and to the channel. Okay, so we've been dealing with exercises from a manual that is dealing with some topics of indices, set theory, number system, logarithms, surds, sequences and series, binomial expansions, probability, and functions. And if this is your first time of coming across my videos, please consider subscribing. Thank you very much. All right, the exercises, which contains about 62 questions, has taken us about 5 sections already, and this one is the 6th. So if you check the title, I said part 6. All right, and we hope to finish all here now. So we have covered down to number 50. Okay, so we have covered down to number 50. Okay, that's this. And right, and then in this particular section we hope to begin from number 51 and to finish in this particular section. So we are going to question 51. All right, and these questions are strictly from functions, or what you can call relations. Okay, all of them. Okay, so let's get into it immediately. All right, now the first question, which is 51, says the domain. We should find the domain of the relation. And so a relation was given. And what is a relation? We are given something like this, brace brackets, and then we have 3, 5, and then you have 4, 9, and then you have 10, 13. Okay, so and that's all, and we are asked to find the domain. In fact, they say the domain is dash. Okay, so you're given a space to fill in your domain, and it's very simple. Remember that your domain is always a set. That means the set of values for which a function or a relation is defined. Okay, so and they are usually the set of the values of x, usually the values of x. And whenever you have a representation in the Cartesian order, like what we have here, this is a pair. So whenever you have a pair like this, you know that it is always symbolic of your xy Cartesian representation. Okay, your xy pair, and that means the first entry in that is always your x, and the second entry is always your y. So what that means is that our domain, it will just include 3. You pick out 3, pick out 4 here, and then pick out 10, all the first entries. And so you close your bracket, and that is the solution for 51. And so we are done. We go over to question 52, and then there they said from the same set they are now asking us to pick out the range. Okay, so and what is the range? The range now represents the y component of the same pair. Okay, so your range will now be 5, 9, and then 13. It's not a big deal. And so, and that is all for that. Okay, so we go over to the next one. Let's say number 53. Okay, so for 53, we are told to the equation. Look at the question here. It says the equation y equal to 4x minus 6 defines a function. Permit me to use some of these short to enable us write fast. Defines a function with independent variable dash, and a dependent variable dash as well. Okay, so you see this one is just trying to see if you understand the definition of dependent and independent variable when it comes to definition of functions. All right, so if you have y equal to 4 x minus 6. You can see that your y is a function of x. That means your y depends on x. The values of x here will determine the values of y. For instance, if I say let my x be 0, so it means that my y is going to be minus 6. So I would need the value of x to get that of y. So my x is now the independent variable, while my y is the dependent variable. So that's all they want you to do in that number 53. So you are done. Just fill in there with x and then what? Y. Okay, so we go over to number 54. So for 54 we are told that the same function for y equal to 4x, look at it, the function y equal to 4x minus 6 includes the ordered pair. Remember I mentioned ordered pair before. Includes the ordered pair, then you are given 5 comma dash. Okay, so these are just tricky questions to see if you understand really what a function is. So this function, like I said in the previous exercise, that if you have a value for y, x, it will give you a value for y automatically. And I used x equal to 0, so immediately you get y equal to minus 6. So these two now will produce an ordered pair. And what is the ordered pair? 0 and minus 6. Remember, like in the 51, I told you that your x is always on the first entry, while your y is always the second. So the implication of this is that you are giving x as 5. That's actually what they did here, and they're asking you to find y. So all you need to do is just to substitute your x as 5. So you have 4 times 5 minus 6, and this is going to give you 20 minus 6, which is 14. So you fill in here with 14 in your material, and that is the solution of that. Over to number 55. Okay, so for number 55, this is what they said. For a function, for the function f of x equal to minus 4x plus 2. Okay, so they are asking you what will be the value of f of minus 2. Okay, so they said is equal to dash. So in other words, it's still the same approach. You are only expected to substitute x. You can see it here. X was removed and replaced with minus 2. So when you come into the function, we call this evaluation of functions. So when you come into the functions, you remove the x and replace it with minus 2. Remember, this thing is multiplication, so you are going to multiply these two, and then you still bring down your plus 2, and so your answer will be minus 4 times minus 2 will give us minus 8, and so we have 8 plus 2, and our answer is what? 10. So you fill in there with 10. That's all. And then again we go to question 56. That's exercise 56. And what's that going to be? So there we are told that for the function g of x is equal to the square root of x. So you're given a function g of x equal to the square root of x, and you're asked to get g of 9. All right? They said g of 9 will be equal to dash. Okay, the same thing I just did earlier. So my solution would be that I have g of x to be this, and you're asking for g of 9. So all you have done is to replace my x with 9. I will come into your function and I will do the same. The law of Moses holds here, an eye for an eye. Okay, and you are done. The value for g of 9 is equal to what? 3. So come here and fill in your 3, and that is that. Okay, so we go again to number 57. Okay, so let me move up now. So for 57, we are, okay, it says match the description in column 1 with the correct response in column 2. Some choices may not be used. Okay, let me try to see if I can produce what we are given in column 1 and column 2. Okay, so let me use this to divide into columns. Okay, so this is what they said is column 1. Let me still write it. Column 1 and then column 2. All right, so the first thing they wrote there, maybe I can use something to denote it. Okay, they said a linear function whose graph has y-intercept. We would need to write out everything they wrote here so that we can do the matching. Okay, so y-intercept 0,6. Then the second thing they wrote there is a vertical line. A vertical line. And the next thing they wrote there is a constant function. A constant function. And then the next we have there is okay, where is it? A linear function whose graph has x-intercept. Let me abbreviate this one because of space. X-intercept as minus 2. Let me use yellow here. Minus 2 and 0. And then he has y-intercept. Y-intercept as minus, is it minus? As 0, 4. Okay, so they're asking us to match this with something that I will write on the this thing. Okay, and then I hope that all of this, okay, I can reduce this, right? And then the next one is that you are given, where is it? Okay, a function, a linear function whose graph passes through where is it? Passes through the origin. Okay, whose graph passes through the origin. Okay, yeah, I think I can remove this to write the last one so that I wouldn't need to shift this up again. So the last one is a function that is not linear. Okay, that is not linear. Okay, so let's complete this. All right, now on the second column, this is what they have. The first one, let me use this, f of x equal to 5x, and then they have second one, they have f of x. Mind you that we are not doing the matching yet, they are just giving you a list, so you are the one that will now do the matching. The next one, f of x equal to minus 8. The next one, f of x equal to x squared. Then the next one, f of x, let me try to shift, f of x equal to sorry, this one is not f of x, this one is x plus y equal to minus 6, and then finally they gave x equal to 9. All right, so now see what the question is saying, that we should match. Okay, excuse me. Excuse me. All right, so we are to match each of these to the one that they define. That's actually what the question is saying. So which one of these on the second column defines a linear function whose graph is has y-intercept, okay, 0, 6. Okay, so which one will do that? Now, what is the meaning of 0, 6? 0, 6 means that it's going to cut the y-axis at, of course, whenever a graph cuts the y-axis, a linear graph cuts a y-axis, definitely it will cut the y-axis at the point where your x will be 0. So in other words, you can see here x is 0. Okay, so all you need to do is to check which of the, of course they gave you only 4 functions here, so check which of them will I substitute x as 0 and I will get my y as 6. So that's the one that will define this particular graph, and that is the second one. So all you need to do now is to match it this way. You can use your ruler. You can use your ruler and draw something. Let me bring in my own ruler. Okay, so use your ruler and draw something of this nature, and then maybe use an arrowhead to show that this is the one it matches to. Okay, and then the next one says a vertical line. So which of these functions represents a vertical line? Okay, how do you know a vertical line? You know a vertical line when only x is given. Okay, so if I have this function here, let me remove this. All of these are what you should be able to play around with, and that's why they are giving you these exercises. So if I have this function here and you tell me, let's say x is equal to 3, I should plot the graph of x equal to 3. Okay, of course you know here will be minus, of course here is the origin 0, here is 1, 2, and then here is 3. So to plot that graph, only x is equal to 3, I'm going to plot a graph that will pass through the x-axis equal to 3. Imagine me, I'm not giving you a straight something. Okay, so something like this, a straight line that will pass through. Remember that we are dealing with linear equations or linear graphs. Okay, so it will pass through x equal to 3, and if I'm able to produce that, it will definitely be a vertical line. And so we can see the only function here that has x equal to something is x equal to 9. So we can draw, let me use green there. So we can draw our vertical line to come and meet this person. So this is the only vertical line that we have there. All right, and then we can put an arrow there. Okay, so that's that for that one. And then which other one? They said a constant function. So what's a constant function? A constant function is a function that is equal to a number, no variable. So no matter what you substitute your x as, it will always give you minus 8. Okay, so this one is straightforward. Our constant function is looking at itself here. All right, and then the next one, a linear function whose graph has an x-intercept minus 2 and then 0 and y-intercept 0 and 4. I will give you there is another way we would have done this. We can use these two things to generate the equation, but that would be a longer distance. It will take us a longer approach. Even though if you understand it, it will still be easy. So, but all I'm going to show you here now is what we did for number 1 here. Just substitute this into any of the functions. Of course, you have taken about 3 of them, so you look at the other ones. So, which one will I substitute my x as minus 2 and I will get 0? Okay, do I have anyone like that? You can see. Okay, yeah, this guy is looking like that. If I put my x as minus 2 here, I'm going to get 0. All right, okay, my y will be 0, but it has to also satisfy this one, such that if you put your y your x as 0, you should also get 4. You should also get 4. Okay, so and if we put our x as 0 here, it is not giving us 4. So it doesn't satisfy what we want. Okay, so that is not the correct function. Alright, so which one does it? If we put x as minus 2 here, we are not getting 0. And then what about this one? If we put x as minus 2, this one comes over here, y will be plus 4, minus 4. That's not giving us what we want. Okay, so you can see invariably none is matching it. Okay, so let's try to see if we can produce the equation. Let me just try. Okay, so there we have, you can actually use, there is a formula we can use, which we have, let's say x minus x1 equal to the slope times y minus y1. That could be an equation. You can use this, right? So from what you are given there, we can actually generate the slope. So the slope is going to be, of course they gave us 2 points, minus 2 and 0, and then 0 and 4. Okay, so our slope is going, first of all, let's fill in this x minus x1. Our x1 here is what? Is minus 2. So this will be minus 2, which will be plus 2, is equal to slope. Our slope will be x2 minus x1 all over, sorry, it should be y2. Although any of them will be the same, but y should be up. Let's try that. Okay, so we will do y first. y2 minus y1, which is 0, all over x2 minus x1, that's 0 minus minus 2. Okay, so this is going to give you 4 all over 2, so our slope is 2. Okay, so we put slope here as 2, and then that is equal to, I needed the yellow, and that's equal to y minus our y1. Our y1 is 0 here, so you have 0 there. Right, so that's giving us x plus 2 equal to 2y. Okay, and then you can take this over to this side, so you have 2x minus 2y is equal to minus 2. Okay, so you see that if you use this function now, if you begin to do that substitution I talked about, that's substituting your x as minus 2, you will discover that you will get y as 0. If I put x as minus 2 here, of course it will cancel the minus 2 on the right side, and then I'll have 0 here, and both sides divided by minus 2 will give me y as 0. So it has ticked this. And if I put my my x as 0 again here, where is the formula? This is here. If I put my my x as 0 there, I'm going to have minus this equal to this, which is going to give me, that's giving me, okay, remember that there we needed, yeah, here if we put x as 0, is going to give us 0 minus this equal to this, and then that is going to be 1 and not 4. Okay, so what is the missing link there? Okay, let's check. Okay, so here we will have, all right, okay, the reason that happened that way is because we use this as our x1, y1. Okay, but then let me bring back this the way it is. Okay, let me bring back. Now, meanwhile, what we are going to have actually is something that will look this way. Look at it. You will have, let's take it, what that is representing is that here is your 0, 4, and then here is your, remember there we had, is it minus 2? Let me check. Okay, minus 2, that means the graph should face the other way around, not the way I'm facing it. Okay, let me remove that again. So this is going to be something of this nature. You draw here, so it will be like this. So here is 0, 4, and then here is minus 2, 0. Okay, so you can actually try to make use of this now to determine what you're looking for. When you're given 2 points is given, so you can actually use it to try to determine your equation now. Okay, so in this case, what will happen here is that you can already see where our that your slope here is actually going to be a negative slope because it's slanting this way. So that means that your x1 is going to be, look at it here, remember that the formula for the slope is y2 minus y1 all over x2 minus x1. Okay, so your y1 here is, sorry, y2 here is 4 minus y1 is 0 all over x2 is actually 0. Then here now you can see that your x1 is minus. Okay, so it would definitely give you the same thing, which is 4 over 2, and that's equal to 2. But if you watch carefully now, you would see that none of this is giving us any equation that is there on the column 2. So that means that guy has no match. Remember, the question says that some of them may not have a match. Okay, so I just had to use all those explanations so that you would understand when we have a conclusion. Okay, and what is our conclusion? Our conclusion is that this person has no match. There is no function on the second column that satisfies the condition for this. So there is no match there. All right, so we move over to the next one. A linear function whose graph passes through the origin. So the a function that passes through the origin is going to be a function where you can have that if you substitute x as 0, you will get y as 0. And that function is the first function here. So if you put your x as 0 here, you'll definitely get your f of x to be 0. So we will join this other function, which is the fifth one here or so, to this other one. Okay, so I can use my arrowhead to signify it. Okay, and then finally the last one says a function that is not linear. Okay, what is the meaning of linear? Linear is that the degree of the function is 1. That means the highest power of x present is equal to 1. And every other function here did that, okay, except the constant function and this guy where x is of the power of 2. So, and that is the one you will match them. Okay, so you discover that only one of the functions on the column 1 does not have a match in our column 2. Okay, and so we move over to number 58. All right, so to number 58, and that is going to give us, the question says that we should find number 58. Okay, it says evaluate each of the following expressions. Let me just write it this way. Evaluate the following. And what are the expressions that we are to evaluate? Let's see them. Okay. All right. First of all, they said evaluate the following. If f of x is equal to x plus 1 and g of x is equal to x squared. Okay, so we are to evaluate the following. The first one there, which is I, they said is evaluate the that is f plus g of 2. What's the meaning of this? So this means that you should add your f and your g, and whatever you get, then you substitute your x as 2. So first of all, we need to get f plus g, and our f plus g is just the sum of this and this, which will be equal to x squared plus x plus 1. All right, so that now means that if we now want to get our f plus g of 2, that means we want to substitute x as 2. That will be equal to 2 squared plus 2 plus 1. 2 squared is 4 plus 2 is 6 plus 1 will give us 7. Alright? And that's the solution to that. So you kindly put that in the space that is provided. Alright? So we go over to the second one. The second one, they said we should find f minus g of the same 2. Okay, so in this case, we are also going to get our f minus g, which is equal to, you are subtracting g from f, and that will be x plus 1, then minus our g is x squared. Alright, and whether you rearrange it or not, you will still get the same answer. So just substitute your x as 2, and that's going to be 2 plus 1 minus 2 squared, and which is equal to 2 plus 1 is 3, 2 squared is 4, 3 minus 4 will give us minus 1 as our solution for number 2. And then again we move over to the third part of that question. Is there a third? Yes. Okay, so the third, they said we should find, we are looking for fg of the same 2. Okay, this time around fg means multiplication, so we are going to multiply f by g. What is our f? Our f is x plus 1. You are multiplying it by g, which is x squared. If you open that bracket, let me bring it down, you are going to have x times x squared will be x cubed, then plus 1 times x squared will still be x squared. Okay, so, and this is going to give us, so if we go up a little bit, we are going to have that, of course, immediately you have gotten your fg now, so you now have to get your fg of 2. That means we are substituting x as 2, and that's going to be 2 raised to the power of 3 plus 2 raised to the power of 2. 2 raised to the power of 3 is 8, and then 2 raised to the power of 2 is 4, and so 8 plus 4 is equal to 12. And that is the solution for the III. Okay, and that's not where it ended. It got up to IV and then even VI. So IV is asking for f over g all into 2. So they used 2 all through. Okay, so in this case it's very simple. Don't even bother yourself. Just put your f over g as, what is f? X plus 1. And what is g? X squared. Don't bother dividing this. Of course you can't divide it because the power of the denominator is greater than the power of the numerator. So you just leave it that way and then try to get your value. So our value, which is f over g of 2, will just be equal to substituting your x as 2, and that will be 2 plus 1 all over 2 squared, which is equal to 3 over 4. You can put this in fraction, in decimal if you want, but it will be better you leave it this way. Okay, so let's go to a new page. I think this page is full, right? And then here we are to, that is to go to V part. And what is the V part? The V part is asking for f composition g and then of 2. So you need to get f composition g. So you now need to know the difference. How do you get composition? So f composition g actually is the same thing as f of g. That means we need to substitute g into f. So the question now is, what is our f? Our f is f of x is equal to x plus 1. And so we are substituting x as g. So this is going to give us g plus 1. And what is our g? Our g is x squared. Then we'll bring our 1. Therefore, what it means is that our f composition g is equal to x squared plus 1. So Prince menos now. And that is our f composition g. And so to get the substitution of 2 now, So this is going to imply that f composition g of 2 will be equal to, anywhere we see x, we replace it with 2. That's 2 squared plus 1, which is equal to 5. Bia. I will stone this boy, yo. Emmanuel! Okay, so we go over to the number 6. All right. So number 6, which is VI, we have G composition F of 2. So we are going to take the same process we did here. What is G composition F? That is going to be G of F. So in this case, we are going to start with G. So because we are substituting F into G, and our G of X is equal to X squared. So if we now put our X as F, that will be F squared. And what is F now? F is X plus 1. So by the time we square it, we will get that our G composition F is equal to, this is going to be X squared plus 2X plus 1. Beautiful. All right. So, and you are done. So that means now that our G composition F of 2 will be, substituting your X as 2, you will have 2 squared plus 2 times 2 plus 1. And what is 2 squared? That's 4. 2 times 2, 4 plus 1. Everything will give you 9 as the solution. Wow, this is interesting. And we are done with number 58. Okay, and then we go over to 59. We just have about 3-4 questions and we are done. Right? So 59 says a polynomial function with leading term 3x. Let me write it. A polynomial function. A polynomial function a polynomial function with leading term. The leading term is 3x raised to the power of 5 has degree dash. That's what they said. What would be the degree of a polynomial function with a leading term? What's the meaning of a leading term? Leading term is like the term that has the highest power. That's what we call the leading term of any polynomial. And remember, we said that it is the highest power present that determines the degree. So that means the degree of this polynomial is what? 5. Okay? So that is 59. So straight ahead, we go to 60. And what's 60 going to be? The question says, for a function to have an inverse, it must be dash. Okay, so for a function to have an inverse, what will happen to it? For it to have an inverse, it must be that we can say it must be invertible. Okay, so in other words, you can actually determine the inverse of that function. So for the inverse to exist, it has to be invertible. Okay, and then again we can say it has to be differentiable and the rest of that. Okay, so but of course the process of determining the inverse of a function, you can use that to also define what will make a function to have an inverse. That means you can actually write the independent variable as a function of the independent variable. Okay, so that is important. So we can just say it must be invertible here, although I will come back to this. Okay, so let's go to the next one, which is 61. Okay, so for 61, we are told the domain of a function, the domain of f is equal to the dash of f inverse. Let me write it. The domain of f is equal to the dash of f inverse. Okay, all right. So and the range of f is equal to the dash of f inverse. Actually, like I would always tell my students, the answer to the question of this particular number is in the question. So just reverse what you are given in the spaces, and then you will get the answer. The domain of f is equal to the range, simple, is equal to the range of f inverse, while the range of f is equal to the domain of f inverse. That's just it. So the answer to the question is in the question. And then lastly, the last question we have here, which is number 62. Okay, question 62. Okay, permits me to put my marker is disappearing. All right. Okay, so question 62 says that you have if f of x is equal to x raised to the power of 3, then f inverse of x is equal to dash. So they're asking us to find x inverse of f inverse of this particular f. That means the inverse of that. Okay, so how do you do that? It takes a few steps when it comes to finding the inverse of a function. The first step is replace f of x with y, and then you have y is equal to s cubed. Then make x the subject. That's the next step. Take this cube to this side. It will be y raised to the power of 1 over 3 is equal to x. So let's switch this. Remember, we are making x the subject, so that will be x is equal to y raised to the power of 1 over 3. So that's the second step. Now the third step is switch x and y. So if we switch x and y, we are going to have y is equal to x raised to the power of 1 over 3. And this other y is not the same thing as this y. This last y now is your f inverse. Therefore, the f inverse of that function is equal to x raised to the power of what? 1 over 3. And that is the solution to that problem. All right, so, and there you have only number 60 for you to verify. I'm leaving that for you now as an exercise. So verify what they want you to do. Of course, it's already an exercise for you, so everyone should complete that. For a function to have an inverse, it must be dash. Already said invertible, so but try to see if there is something else that can fill in that space. Okay, so and that is the end of the exercise. Hooray, we got to the end of this journey. We started from part 1 to part 2 to part 3. Part 1 was on number systems and set theory. Part 2 was on indices and logarithm. I think there was sort there. And then the part 3 had to do with sequences. Okay, that's both arithmetic and geometric progression. Part 4 had to deal with I think binomial expansion, and then later we had probability. Okay, binomial expansion and probability. Then part 5 was now the one we did earlier today, which was binomial theorem. And then this is the part 6, which dealt with functions. So, and that covers the whole topics in the course outline for this course. So this should not just be for solving of the exercises, the manuals you are giving. It should also help you prepare for exams because it is holistic. All right, so and this is where we end it for this video. Have a very nice day. Please, like I said earlier on, subscribe to this channel, we beg you, and then share it with your friends. Of course, it will help them in their exams and whatever assignments that they have. Okay, and so see you in other videos. Always come back here to check for other concepts, and then if you have any questions, you can drop for us. You can make requests for videos and we will respond to you. See you in our other contents. Bye.